Hello students, welcome to my class. In today's class we are going to learn a new chapter, chapter 6, triangles of class 10. In class 9, you have studied many properties of triangles including congruence, but in this chapter we are going to learn another important property, that is similarity of triangles. So before going into similarity, first we will see what is congruence and what is the difference between the concept congruence and similarity. So first we will see congruent figures. What do you mean by congruent figures? Okay, so two figures having same shape and same size, then we can call that figures as congruent figures. So two figures having same shape and same size. For example, see some examples for congruent figures. For example, if we consider a circle of radius 3 centimeter and another circle of radius 3 centimeter. Okay, so these two circles we can call as congruent. Why? Because they are having same shape and the size is also same. Size means the radius. Here for a circle the size is the radius. So radius is same here. So we can call these two figures are congruent figures. Similarly for congruent triangles, when we can say two triangles are congruent if they are of same size. Okay, same size and same shape. So if you have two triangles ABC and PQR, if they have a same measurement, what are the measurements of a triangle? The three angles and the three sides. These are the 6 measurements of a triangle. So these 3 angles and 3 sides of the first triangle and the second triangle are equal, then we can say that these two triangles are congruent, and we will use the this symbol to denote the congruence. So we can write triangle ABC congruent to triangle PQR. Okay, so if these 3 angles and 3 sides are equal for these two triangles, then we can say that the two triangles are congruent. Now we will see what is similarity or similar figures. Similar figures. So two figures having same shape. So shapes should be same but not necessarily same size. Okay, so two figures having same shape but not necessarily same size are called as similar figures. For example, if I am drawing a circle of radius 3 centimeter and I am taking another circle of radius 5 centimeter. Okay, so these two circles I can call as similar figures. Why? Because here the shape is same only. It is having, both the figures are having same shape but the size need not be same. Here the radius is different but the size need not be same. So I can call these two circles as similar figures. So circles are similar. So we can find out, we can see few examples of similar figures. First one circle and another example is square. All squares, if I am taking a square of side 2 centimeter and another square of side 4 centimeter, then these two squares are having same shape but the size need not be same. So we can call these two squares are similar. So what is the definition of similarity? Two figures having same shape but not necessarily same size. So what we can say from these two? Actually this is the difference between congruence and similarity. So what we can say here, see, in congruence also we have same shape. Similarity, definition of similarity is same shape, and in congruence also we have same shape. So from the definition of congruence and similarity, we can say that all congruent figures are similar because we have same shape. Okay, so all congruent congruent figures are similar, but similar figures are need not be congruent. So all congruent figures are similar, but similar figures need not be congruent. Okay, so this is the definition of similarity. So two figures having same shape but not necessarily same size are called similar figures. So now I am going to draw two figures, a triangle and a square. So can you say these figures are similar? No, we can just by seeing the figures we can say they are not similar, because similar figures means they should have the same shape. Here the shapes are not same. One is triangle, another one is square. So these figures are not similar. Okay, now I am going to draw another figure. So here I have drawn two quadrilaterals, ABCD and PQRS. We have two quadrilaterals. So can you say these two figures are similar or not? So here in this example, in the first example, just by seeing the figures we can say it is not similar. But in the second case, it is not easy for us to say whether they are similar or not, because the shapes are same. Okay, because I have drawn two quadrilateral ABCD and PQRS. Here the shapes are same, so we can 100% say these are similar or not similar. So we need some rules to decide whether the given figures are similar or not. In this example, to decide whether these two figures are similar or not, we need some rules. So what are that rules? We will see now. So two polygons of equal number of sides are similar. When we can say the two polygons are similar, if first rule is corresponding angles are equal. And the second rule is corresponding sides are in the same ratio. Okay, so these are the roots. So when we can call two polygons are similar, so the two polygons should have equal number of sides. Then only we can say the shapes are equal, same shape. Okay, two polygons of equal number of sides are similar. Then the first condition is corresponding angles are equal. If the corresponding angles are equal, and the second condition is corresponding sides are in the same ratio. If these two conditions are satisfied by the two figures, then we can call the figures are similar. So here in this example, see here, if A and P are equal, angle A and angle P are equal, angle B and angle Q are equal, angle C and angle R are equal, angle D and angle S are equal. So corresponding angles are equal and the corresponding sides ratio. So AB by PQ is equal to BC by QR is equal to CD by RS is equal to DA by SP So, if these two conditions are satisfied for these two quadrilateral, then we can say that these two quadrilateral are similar. That is, corresponding angles are equal and the corresponding sides are in the same ratio. Actually, this same ratio we can call as scale factor. This same ratio only is called as scale factor. Okay, so we can say that this quadrilateral ABCD is similar to PQR. So this is the symbol used to denote similarity. So quadrilateral ABCD is similar to quadrilateral PQRS. When we can say two quadrilateral are similar, if the corresponding angles are equal and the corresponding sides are in the same ratio, then we can say that the two polygons are similar. Now we will go to exercise 6.1. So exercise 6.1, first question is fill in the blanks. Actually this exercise is very simple, very few questions only you have. So the first question is fill in the blanks. All circles are, what is the answer? Similar. I already explained all circles of any radius are similar. All squares are also similar only. If you take a square of different length, then they are similar only. Why? Because the shapes are same. Then third one, all dash triangles are similar. All equilateral triangles. So the answer is equilateral. Equilateral triangles are similar. So we got a few examples for similar figures. Circles, squares and equilateral triangles. All these are examples of similar figures. Now the fourth one, two polygons of the same number of sides are similar if their corresponding angles are, we have already seen this rule, corresponding angles are equal and their corresponding sides are in the same ratio. Another word for same ratio is proportional. So the corresponding sides are proportional. Question number 2, give two different examples of pairs of similar figures and non-similar figures. So here we have to give examples for similar figures. So we have already seen circles, square and equilateral triangles. These are all examples of similar figures, and non-similar means if you take a circle and a triangle, it's not similar. Similarly, you can take a square or square and circle. So these are examples of non-similar figures. Question number 3, state whether the following quadrilaterals are similar or not. So here in this question we are given two quadrilateral PQRS and ABCD. So here if you see, when we can say two polygons are similar if their corresponding angles are equal and the corresponding sides are in the same ratio, then we can say the polygons are similar. So here the quadrilateral, what we have is two quadrilateral, and here if you see in the second quadrilateral ABCD, all the angles are 90 degree, but in this quadrilateral PQRS the angles are not same. See, it is not, all the angles are not 90. So here the angles are not same. Even if the sides ratios are equal, the corresponding angles are not same. So here if you see PQ by AB or RQ by BC or RS by CD or SP by DA, all these sides ratios are 1.5 by 3. That is 1 by 2 only. All the sides ratios are 1 by 2. So the sides ratios are same but the angles are not same. So these two figures are not similar. We have seen the introduction of the concept similarity and we have completed exercise 6.1. So the remaining concepts we will discuss in the next video. If you like my channel, you can share and subscribe. Your subscription, my motivation. Thank you, students.